Hello, my name is Luke Kaufman, and I am a freshman at Turpin High School, and I am based in Anderson Township. So here's my project, Impact of Glucose on Saccharomyces cerevisiae. So my hypothesis is that higher concentrations of glucose will result in a higher overall growth rate as well as cell density. So here's a picture of the lab that I made in my basement. So there's media, which was made up of water, dry malt extract, as well as the yeast, which would grow after we put it in the bottles. And so I put balloons over 3 of the bottles in order to form a triplicate, which are identical in terms of time made as well as the amount of glucose in their bottles. So the balloons are made to trap CO2, which will be released in the process of glucose metabolization, which is a required step of making energy and will show that the yeast cells are doing well and still reproducing. So higher levels will show everything's going well. I'll use this caliper here in order to measure the balloons at a certain point each time, which is marked, in order to be specific, as well as consistent with each measurement every day. Yeah. So another one of my methods of measuring amount of growth is a microscope, where I'd put the media into a slide and take pictures of it and send it to the computer, where I'd use a program from the National Institute of Health, which would hopefully give me accurate cell counts on the images. So back to the balloons to talk about the results. So the balloons had higher growth rates in the beginning, as you can see by day 3, where they're starting to inflate, while some of the higher concentrations have not begun inflating yet. As well, by the day 7, the lower growth rates have completely deflated or begun deflating, while the higher growth rates are still continuing to rise. Now, there were some issues though for triplicates. Sometimes one of the balloons would begin to deflate before the others, or just wouldn't grow as much. My theory on this is that the balloons may have thickness differences, which would prevent some balloons from growing as high as others, or there may have been small holes which allowed the air to escape, and that caused the deflation. So that wasn't as reliable as our microscope, which gave a similar trend with data starting out slowly for the higher concentrations, but then slowly hitting its peak at 300,000, while the lower concentrations hit their peak at 60,000, which is 5 times less, but it grew a few days sooner. Okay, so yeah, it's the same trend with slightly better data, as it's more consistent than the balloons which deflated and all that. So you can see it's consistent by how each day the lines, the bars, are approximately the same height. So yeah, microscopes show that low sugar would have a high rate, while high sugar would have a high density. Alright, so onto my reasons for why I believe that what occurred happened. So I think the low sugar ran out of nutrients, which caused it to have a lower cell density than the higher concentrations, while the higher sugar had lower rates at the beginning because of passive transport. So in this case, passive transport pretty much just means that since there is so much sugar in the water, the concentration of H2O was lower, which means that yeast wasn't able to efficiently get enough water to remain hydrated enough to reproduce to maximum efficiency. So it took a few more days to get up to its peak. So there are some real world impacts that this could have, being in breweries and bakeries. They need a certain amount of yeast, and it's cheaper to grow on their own. And so if they know how to grow yeast with percentages of sugar, they can maximize their efficiency and reduce costs in having to buy additional sugars or yeasts. Sorry. And with less costs and higher yeast, they'll do better than the bakeries and breweries that don't. Thank you for listening to my presentation over my project. And that is all.